Okay, so hello everyone. In this video, we will cover networking devices. So, in this video, we will discuss about various networking devices like cables, repeaters, hubs, bridges, switches, and routers. And in security devices, we will discuss about gateways, firewall, and IDS. So, let's start. Generally, we use a lot of devices in computer networks. Some devices are pure hardware, and in some devices, hardware and software both works. Okay, so all these devices that works in backend at the background. So in those devices we have cables, repeaters, hubs, bridges, switches, routers, gateway, IDS, firewall, and modem. Okay, so if we talk about these devices, we'll see these devices one by one completely in detail in this video. Okay, here I am giving just a simple introduction in this slide. Okay, cable, repeater, and hub. If I would talk about these three devices, then these are pure hardware, means no software works in them, and these are layer 1 devices, means they work in physical layer. Okay, bridges, switches, and routers, these are very important devices and they have hardware and software both. Okay, means they have software working in it, because of that their price will be obviously more, or like we can say high. Bridges and switches are layer 2 devices and router is layer 3 devices, mean bridges and switches work in data link layer and router is in network layer. Same way, if I would talk about gateway, gateway is generally a term, it's not actually a device. Gateway is generally a term, means door. In gateway we can use firewall, router, and we can use proxy servers and all. Okay, so we call it gateway. IDS intros the detection system. We generally use these devices for security purposes. Okay, it's not like only these two devices gets used, but generally two most important devices are IDS and firewall. Firewall and IDS intros the detection system that we use for security. Okay, this is modem. Modem that you definitely must have seen in your homes. Like also, modem basically means modulator or demodulator. Okay, means computer software works in 0 or 1 form, as we discussed in our last lecture. Okay, means it works on digital signal, the data that we are sending in digital data, but the wires getting used to at the back end, they have analog signal. Okay, so digital to analog or analog to digital conversion is basically done by modem. Okay, moving forward to our first device, which is cables. So in computer networks we use different type of cables, and why we use them? Generally to connect various devices. Here we have different type of cable: unshielded twisted pair cables, coaxial cables, shielded twisted pair cables, fiber optic cables. Okay, so first we are talking about unshielded twisted pair cable, or we can say UTP or STP cables. Okay, so if I would talk about UTP, then so in majorly we use in them 10 base T or 100 base T. Okay, sometimes it is written like 10 base T or 100 base T. Okay, if this comes written, so what is the meaning of this? So what 10 means here? 10 mbps. Okay, this is what 10 megabits per second. What is 10 means here? 10 megabits per second here, and in 100 base T, 100 megabits per second. Okay, this we call bandwidth. Bandwidth means how many bits we can transmit per second. Okay, so what 10 denotes here? 10 megabits per second, meaning that I can transmit 10 megabits of data in 1 second. Okay, base, what is base here? Now we have two terms in computer networks: baseband and broadband. Baseband and broadband, what does baseband means? Now if there is a wire and a signal is already passing through the wire, so no other signal can pass through it at the same time. Okay, means at a time only one signal can transmit, only one signal can go. If any other signal comes at the time when there will be collision between them. Okay, this is baseband. And in broadband we use where multiple signal can move parallel. So next is T. We have discussed about 10. 10 means 10 megabits per second, and then base means one signal at a time. Then now T means 100 meter. Let's say length of wire is 100 meter. Then this signal, if we talk about UTP, how the signal moves in it? In the form of electrical, means electric signal is moving in UTP. So when electrical signal is moving, it can move up to 100 meters only. Okay, after 100 meters, what will happen to its energy strength? It becomes weak. Okay, means after 100 meter, what will occur in it? Attenuation. We can say attenuation will occur after 100 meter. What does attenuation mean here? Strength of the signal becomes low, means its energy becomes low, it can't travel further, so the signal can travel up to 100 meters. So 10 base T means signal can only travel to 100 meters. Therefore, we use them in Ethernet LANs, local area network, means less than 10 kilometers. Earlier, we used to say less than 1 kilometer or 2 kilometer, but in today's time, the LAN in your offices, organization are generally less than 10 kilometers. So there we can use UTP, STP cables. Then we come to coaxial cable. In coaxial cable, also the signal is electric. Okay, then here we can see common types: 10 base 2, 10 base 5. what is the change here? The 10 is exactly the same, 10 megabits per second. Base is exactly the same, base means one signal at a time. Now what does 2 mean here? 10 base 2 means 200 meter, means distance is increased, means signal can travel more distance. After 200 meter there will be attenuation, or in 10 base 5 case you can say attenuation will after 500 meters, so the signal can't move more than that. Okay, so this is what coaxial cable. Now we come to fiber optics. In fiber optics electric signals are not there, there is light signal. Okay, signal is in light form. Okay, you can transmit at 100 megabits, we can see 100 megabits per second. It is baseband, means one signal at a time. It is baseband fx here means fiber channel, and distance here is 1.9 kilometer, or you can say approx 2 kilometer, means signal can move up to 2 kilometer. If you are using 100 base fx, apart from this 1000 base fx is also there. Many different versions are available in fiber optic cables. So this is what fiber optic cables, and this is all about the cables. Now we are talking about key points of cables. So attenuation, first is attenuation. We have seen that signal weakening after traveling a specific distance is what? Attenuation. Okay, our signal strength is decreasing, this is attenuation. Okay, now maximum possible number of collisions. Okay, so we have seen that there was a baseband connection and broadband connection. We have seen that in cables there is a baseband connection. So if all the devices started sharing signal at a time, then there will be collision. What are the possible number of collisions? N. Where what is n here? N is number of connected devices. Let's say there are 4 devices, then maximum possible collisions are 4. Okay, now moving forward to filtering. What is filtering? Means cable cannot filter data, because cable is pure hardware, they cannot filter data or filter signal. We can say that if A wants to send a message to B, then the signal is sending all over the cables, and C and D port will receive that signal also. So cable does not have that functionality to stop that signal. So this is filtering, cables cannot filter the data. Now let's talk about the repeater, the very important topic. Repeaters generally works in physical layer, means it is purely a hardware that don't have any role in data link layer. It is a 2-port device that connects 2 cables. Okay, so first of all, why repeaters are used? So the first reason is, let's say there is a 10 base 2 cable. Okay, as I have discussed 10 base 2, what is meaning of 2? 200 meters, means I have made a LAN of 200 meter and I have connected various device to it. Now if a signal moves here, up to where it can go maximum? Okay, up to 200 meter. After 200 meter what will happen? Attenuation, means its strength will go down, and this means signal will become corrupt. Okay, lost, and it will not be any useful. So what we have to put here? A repeater. What repeater does? It raises that signal, means it regenerates the strength. Okay, strength of the signal, regenerate the strength. Here many time it is asked the same work is done by amplifier also. What is the meaning of amplifier? To amplify the signal. Are repeater and amplifier the same thing? No. What amplifier does? Suppose strength of the signal at starting is x. Okay, it goes down from x, then what amplifier will do? It can make it 2x or 4x, so it will increase it very much. So but if we are using repeater here, original strength is x, repeater will regenerate and make it to equal to x, means as the signal moves it, the strength will decrease from x. So what repeater will do? It will take a bit by bit and give it original value, it will make equal to that. Repeater will always make equal to original strength. So, and what is the benefit from it? Here a device is sending, so after 200 meters there will be attenuation, but because of repeater it can travel even after 200 meters. So how much the signal can totally travel? 400 meters. So what I have increased here? Distance covered by the signal, distance covered by the signal we can increase with the use of repeater. Apart from this, what is asked here in the exams? Forwarding. Does repeater do the forwarding or not? Forwarding means, let's say A has to send the message to B. So as the A sends message to B, when the message reaches repeater will forward it and place it in complete link. Okay, next is filtering. Can repeater filter? No, repeater can't filter. Will the repeater will send the signal further? Yes, it will send the signal further. Filter means we have to stop the signal. Okay, as we discussed in the cables too. Okay, now next is collision domain. If we talk about collision domain of repeater, what is the maximum number of collision possible? N. What is n here? Number of devices connected both sides, where the collision will be less, where there is a buffer inside. Okay, what a buffer will do? Keep the packet and forward it, store and forward method. So there is no buffer in repeater. Okay, if there is a buffer or memory, it will keep putting signals there, then it can check. But such functionality is not in the repeater because it is purely a hardware, no software in repeaters also, because these are layer 1 devices. They works in physical layer, repeaters and cables. Now next device is hub. So in hub, always remember that hub also works on a physical layer. Working on physical layer means it is purely hardware, no software works in hubs. Okay, the hub is multi-port repeater. We can say hub is a multi-port repeater. Here I have written the bold point, hub is multi-port repeater, because repeater is a 2-port device by default. Okay, but hub is multi-port, as I shown in the diagram also. So you can connect different devices to it, like I mentioned in the star topology. So you can connect multiple devices with the hub because there are different ports available in it. If we are using repeater to connect two cables or devices, so if there comes any problem with the wire, if there is any cut or like any other issue with the wire, then the repeater won't tell anything. But here in the hub we have the extra functionality also, because it is dedicated device. So here you can say, here a very small LED blinks and tell there is a problem or power is on or off. So hubs provide these type of extra functionalities that repeater don't provide. If we would talk about technical terms, then forwarding. So do hubs do forwarding? Yes. Means if sender wants to send data to receiver, so when sender sends the data, when it will reach the hub, then will hub forward it ahead? Yes, it will obviously do forward. Hub broadcast the data to all the ports. This is the functionality of hub. Hub will broadcast the data to all the ports. Now next is filtering. Let's say if device 1 is sending message to device 2, so if 1 sent a message, then it will surely reach to 2, but along with 2 it will go to 3 and 4 also, as there is no filtering, because this is not a software, just pure hardware. So it can't decide for which MAC address or interface is this message for. Okay, collision domain. Collision domain, if we talk about collision domain in this hub, collision is not possible outside, but is it possible in the hub? Yes. If one sent a message, then signal reached to hub. At the same time, second device also sent it, then third device also sent it, then 4 also, then all 4 signal will collide with each other. So if there are n number of devices, then total number of possible collision is n also. Okay, moving forward, the next device is bridges. We use bridges in computer network to connect two LANs. Okay, so if we would talk about hubs, as I said in hubs video, we can use hub also to connect two LANs. But in bridges, remember that bridges are used to connect two different LANs. Okay, we are connecting two LANs in hubs also, but in bridges we are talking about two different LANs. Okay, bridges can connect two different LANs. So the important point here is two different LANs. Means if I'm using the bridge, then it may be possible that we are using token ring LAN at one side, and one other side we are using token bus LAN, as we discussed in our previous lectures also. And why it is named bridge? Generally, if you would talk about bridges, so if you want to connect two different areas, then where we use bridges. Okay, we generally use flyover, we can call it bridge also. So we use the bridges to connect two different lanes, like two different areas. Okay, the next point is forwarding. Forwarding means that if packet arrives towards bridge, then does the bridge forward it ahead? Yes, it will forward packets between LAN based on MAC address table. So bridges work on physical layer and data link layer. So data link layer means that bridges can check MAC addresses. Checking MAC address means that they can decide if they have to send the packet ahead or not. Okay, let's say if A is sending the packet to D, when A sent data to D, then the bridge will check if the destination MAC address is on the left side or right side. If the MAC address is on the right side, then it will forward ahead. Okay, then bridges can definitely forward the packet. Okay, but let me tell you one thing, how they can check the MAC address in the case of filtering. Filtering is like, if I want to block or stop the packet, let's say A is sending the packet to C. If A is sending a packet to C, then message will reach to bridge also. Okay, but in this case, the bridge can also recognize that C is on the left side, so it doesn't have to send packet to the right, packet ahead. Okay, this concept was not in repeater or not in hub. Okay, but in the bridge, because there is a data link layer involved, that's why MAC address gets checked here. Okay, here we will talk about how to check them. Bridges are generally two types, static or dynamic. Static bridge means that bridge generally maintain a table like routers maintain a routing table. Okay, same way bridges also manage a table including MAC address and port number. So static means fixed. In this case, the network administrator manually types which machine is connected to which port. As you can see here, M1, M2, M3, all the three machines are with port P1. Then the administration will type manually that all three are connected with P1, and M4, M5 and 6 are connected with port 2. Then the administrator will type manually actually that these machines are connected with P2. Now the bridge has this table. Okay, now if M1 wants to send a message to M5, then that message will include source address of M1 and destination address of M5. When it reaches the bridge, then the bridge will check the destination is M5 and M5 is on the port 2. Okay, port 2 means it will forward this packet to the other side. So this is actually called forwarding. So forwarding is done according to this table in static bridges. Filtering means let's say M1 is sending a packet or message to M3. When M1 is sending the packet to M3, so when message will go and reach the bridge, then the bridge saw that the destination address is M3, then it is checked in table that M3 is connected to the P1 port, then it will observe that M3 is on the same side, so it will not forward the packet and filter it. Filter means stopping and blocking our signal. So we obviously have to block this packet because M1 wants to send it to M3. Then why would I forward it ahead? We don't have to create unnecessary traffic. Then bridge stops this type of the packet. We are able to block because of the data link layer and MAC addresses. But if we would talk about static bridges, then there is a lot of problem in it. If the MAC address of the device got changed, or if I change the MAC address, let's say if I change the MAC address of M2, then we have to manually type it again. So we generally use static bridges less. We use dynamic or transparent bridges more, because in static bridges we have to manually type again and again and again. If we talk about dynamic bridges, then in this starting there is nothing in this table, there will be nothing. It means the whole table is empty means there is nothing typed until now. Then in this case, let's say M1 sent a packet to M6. Okay, so when it will send packet and it reach the bridge, then bridge observe that M1 is source address and M6 is destination address, but there is no entry in the table. Then how it will do the task? So the first time it will broadcast means it will forward ahead or to all the devices. All the devices will get it. This packet means packet will reach everyone. Okay, when this packet will reach everyone, then first of all it made an entry that packet came from M1 and M6 is the destination address. Then it will find out that the packet from M1 came through the port 1. So it made an entry like M1 port 1. When M6 got this packet, and when it will send the reply that it got the packet, it will send acknowledgement that it got the packet. So when M6 sent the reply, then there will be source address M6 and destination address M1. So when this packet reach the bridge will say okay, M6 is connected to port 2. Then it will mention the entry here, M6 is connected to port 2. That's how dynamic bridges work. Okay, and that's how this will create the table. Next, the collision domain. Collision domain means bridge use the store and forward strategy. It means that it stores the packet and forward it after processing it, as we discussed earlier. Okay, so it means that bridge has its own buffer or memory, we can say. So if a packet arrived, then it stored it in the buffer. At the same time another packet arrived, then stored it also in the buffer. There will be reduced collision. Okay, the collision domain is very less. Now moving forward to switches. So what is switch actually? We have studied about bridges that it's a two port device. Means let's say we have port on both side of the bridge. I connected LAN 1 with port 1, and on the other side I connected LAN 2. So we use bridges to connect two LANs, but it's different from bridges because it has multiple ports. Okay, as we seen in repeaters and hubs also, hubs has multiple ports. It was a repeater, but it was a multi-port repeater. That's why switch is called a multi-port bridge. Okay, and we use switches to connect different devices as shown in the images. This way we can connect different devices with it, and it helps a lot in whole internet system, because we are not connecting to the router directly, we are connecting to the router through the switch. Okay, it's a full duplex link. Means if a data is going from a device to the switch, then data can go back from switch to same device also parallelly. There will be no collision. This is the reason why collision in the switch is zero. Its collision domain is zero because it's full duplex. There will be no collision with each other. Our next device is router. We use router basically to connect two different networks. The first important point is that when we talk about routers, by default you should get internet in your mind. We are talking about internet. What is internet? A collection of different networks. Okay, so here whenever we talk about router, we are talking about internet, meaning about WAN means wide area network. In all the devices we have talked about LAN, local area network. In routers we are talking about wide area network. Router works on three layers: physical layer, data link layer, and network layer. Data link layer means router can check MAC address, along with it can check IP addresses also. The next important point is forwarding. So when the packet reaches router, will the router forward this packet? Yes, it routes packets between network based on routing tables. Routing table means it maintains information about which network is connected to. Okay, if the router is unable to decide about the direction in which the packets should be sent, then what it do? Flooding means sending in all direction, a kind of broadcasting. It can send the packets in all the direction. This is an important point. Okay, next is filtering. Can a router filters our packets? Yes, it can stop packets based on routing rules. Okay, like blocks, ARP requests and all. Okay, next is collision domain. Collision domain, can packets collide inside the router? No, because router uses store and forward method, just like switches, as we discussed it in switches also. It uses routing protocols like RIP, like routing information protocol, distance vector routing protocol, and other advanced protocol. Okay, so that's all about router. Now we have seen six devices, six major important devices. Now remaining four devices I have talked about it. What is gateway? Gateway is conceptual term rather than a specific device. Okay, and now what is firewall? Firewall is security devices that monitor and filter network traffic. What is IDS? Intrusion detection system, security system that monitors network for suspicious activities. And now what is modem? Modem convert digital signal to analog signals, like it is working as modulator or demodulator. Okay, so these are all the devices. So that's it for this video, and this is very important video. So we will meet in next video. Until then, bye bye.